Okay, so let's extend our thinking around this rational function. This is something that you did in pre-calculus, so before calculus is graphing a rational function, and you learned about its characteristics. Now we want to take some of those characteristics we discussed before and convert it into some calculus knowledge and calculus statements. So these statements here under pre-calculus statements should be some statements that look familiar to you. You examined things like in behavior in your prior math classes, and you wrote statements like this. As x approaches negative infinity, the graph of f of x approaches what? So remember that arrow means approaches. And so basically we're just asking, okay, as x gets closer to this value, what is y getting closer to? And we're going to use the graph that we just created to answer this. So as x approaches negative infinity, and we'll go back to our graph, as x approaches negative infinity, as x gets more and more moves to the left very far, what is the y value it's approaching? And hopefully you can see in the graph that that y value is 2. It's approaching the horizontal asymptote. All right, as x approaches infinity, the graph of f of x approaches. And because of that horizontal asymptote, you can look back at the graph and see that the y value it's approaching here is also 2. So now we want to convert these statements into calculus statements, into what we call a limit. The answer that we wrote in both of these blanks is our limit. Our limit is 2. So basically, whatever y value you're approaching is your limit. That is one way we could informally define what the value of a limit represents. Basically, as we approach some x, the limit is the y value that we're approaching. Not necessarily the y value we reach, but the y value we're approaching. So to write this statement that you did prior to calculus, in limit notation, we would write LIM, that's the abbreviation for limit. Underneath that, we would write the x value we are approaching. In this case, we're approaching negative infinity. Then we would write our function, and we could write out the function 2x squared plus 5x. We could write out the actual equation here, but we're just going to write f of x to make it a little shorter. And then we write equals, and we write whatever our limit is, whatever the y value is we're approaching. So we write the limit, or we read this, the limit as x approaches negative infinity for f of x is 2. Everywhere we see an equal sign, we would say is. So the limit is 2. The limit is the y value we are approaching. So the value of the limit represents the y value in the graph that is being approached. Okay, so let's try a couple more. We want to take this next statement and also convert it to the limit notation. So in this one, we would write limit as x approaches infinity for f of x is 2. So these statements are equivalent. We're just learning a new way to write it using our new calculus vocabulary. Okay, as x approaches negative 3 from the left, so we've got to go back up to our graph, and we've got to say, as we get closer and closer to negative 3 from the left-hand side. So as I approach negative 3, I'm going to trace my graph, trace it, trace it, trace it, trace it, coming in from the left. And as I get close to negative 3, I want to say, well, what is that y value that I'm approaching? And it looks like I'm approaching the whole. So we need to remember and go back, oh yeah, the y value of the whole was 7 over 6. So as I approach negative 3 from the left, I'm getting closer and closer to becoming 7 over 6. So that would be our limit. Now let's look at it from the right-hand side. If I examine and trace my graph coming in from the right-hand side and getting closer and closer and closer and closer to negative 3, again, I'm trying to reach the whole. So again, the limit would be 7 over 6. So these two limits have been separated in our statements. We've got what is the value as x approaches negative 3 from the left, and we identified that as 7 over 6, and then we have from the right. Sometimes these limits might be different. Okay. Now, to to indicate this in our statement, we would write as x approaches -3, and then to indicate that we're only looking at the left-hand side, we put this little negative up here at the top of the -3. Still write our function, and equals 7/6. For this one, we would write the limit as x approaches -3 from the right. We would indicate the right with a little plus sign. F of x is 7/6. Okay, now let's look at 3 from the left and 3 from the right. So we need to go back to our graph and examine approaching 3 from the left and 3 from the right. As you recall, x equals 3 is a vertical asymptote. So as I approach 3 from the left, on the left side of 3, the graph's just going down, 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 and approaching negative y values. And they grow larger, larger in that negative direction, which actually means they're smaller. But it approaches that negative infinity. And then as I come into 3 from the right, the graph just continues to go upward, approaching infinity. So I would write in my statement that as I approach 3 from the left, I'm approaching negative infinity. And as I approach 3 from the right, the graph is approaching positive infinity. So the limit as x approaches 3 from the left of f of x is negative infinity. And as I approach 3 from the right, it would be positive infinity. So again, all the statements in this box on the left and the statements on the right are equivalent. There's just two. We've just learned a new notation. This is your first calculus vocabulary word, a limit, and your first calculus notation. We're just converting things we've actually already been doing into calculus statements. Okay, now let's take a look at how this looks in a table. I have on the next page filled in these tables for you. This is the same function, but instead of looking at the graph, we want to look at a table of values. So let's pretend like we've never seen the graph, and we want to evaluate the limits from the table. Okay, so what we need to do here is to find the x value we're approaching and then examine it in the table. What are the y values approaching? So this is as x approaches negative infinity. So we would read these tables going out here. As x gets more and more and more negative, what's y getting closer and closer to becoming? And you can see that these numbers, these y values, are slowly approaching 2. And hopefully you remember that from before because there's a horizontal asymptote at 2. Same thing here is that as I approach infinity, x values get bigger and bigger. The y values are getting closer and closer to 2. So same problem from up above, but just another way to find the limit. You're going to be asked to find limits both graphically and numerically. Numerically would be from a table. All right. Let's look at the next example. Here we're approaching -3 from the left and the right. So as -3 in our table would fall right in here in the middle. Here's -3. And notice I picked values on the left and right hand side that are very, very close to -3. You don't want to look at values too far away from -3. And in fact, -4 is too far away from -3. We want to look at values that are extremely close. So as I come into -3, coming in from the left, I want to say, what are these y values getting closer and closer to becoming? And as I come in from the right hand side, what are the y values getting closer and closer to becoming? And you can see they're zeroing in on that same value of 1.166. Hopefully you remember that's where the hole was, and 7/6 is approximately that decimal value. Okay, one more evaluation using tables. Again, this one can be deceiving. You have to be real careful. We're approaching 3 from the left and the right. So here's 3 in our table. As I come in from the left, these numbers are changing drastically. They're growing very, very large but negative, so actually getting smaller and smaller and smaller. But they're not approaching anything particular. I'm not going to say the limit from the left of 3 is -4,998, because if I carry out more decimals, I'm going to get an even crazier number. Same thing happens when you come in from the right. These numbers are just growing larger very fast. So what we need to recognize is for this limit, the value of the limit from the left would be negative infinity, and from the right would be positive infinity. And we saw that in the graph where we had the vertical asymptote at 3. So now you've witnessed how to find limits graphically and numerically from the same function. So hopefully, because it's using the same problem in 2 different ways, it allows you to make the connection between how to read the table and the graph and get those same answers.